Okay, you'll probably want to pause this video and take some notes along the way, but we're given that angle C in some triangle is 33 degrees, and that the side opposite, which is this C right here, is 43. And I always like to say that the other side, so this is C, little c, is the included side of the given angle. So this is B equals 46. Now the question is, how do we find out if there's 0, 1, or 2 triangles? And the key is to determine the length of that altitude and compare this side opposite with the length of that altitude. So let's go to board 2. Here's the situation. This is the given angle. This is the side opposite. And this is the adjacent side. And you can see here that this says that there's 2 triangles. The question is why? Well, if you picture this opposite side on a hinge, question is, will it hit this horizontal side in more than one place? And as long as it's longer than the altitude, which we can find the altitude right here by right triangle trigonometry, the sine of 33 equals h over 46. So h is the sine, is 46 times the sine of 33, which is this number right here. And as long as the opposite side, 43, is greater than h, but less than 46, you'll have 2 triangles. Let's actually see why. Here's the depiction. Now focus on this opposite side of 43. And you see as it hinges, it's going to hit the horizontal side, boom, right there. And it hits it there also. That's why there's 2 triangles. And you're going to see what those 2 triangles look like on the next 2 boards. Okay, here's one triangle, which we start this way. We know the side opposite an angle that we are given. So the sine of 33 is to 43 as, well, we got to find B first, angle B first, because it's opposite the other side that we know about. So as the sine of B is to 46, solve for B. And you can see I multiplied both sides by 46, then took the inverse sine of this expression, and there's what it is right there. The inverse sine of 46 sine of 33 degrees divided by 43 is 35.64 degrees. Once you know 2 angles, you can always find the third angle by adding them together, the 2 that you know about, and subtracting from 180. So that's what this angle is. And once you know that angle, you can find the side opposite that angle using the law of sines again. Here's where I did that. Little a is to the sine of its opposite angle, as 43 is to the sine of its opposite angle, which results in this, which is 73.53 units, whatever that is. Okay, and once that's one triangle. I think your problem statement said to call this angle 2 because it's the larger of 2 angle A's. Let's see. Said A1 is smaller than angle 2. Okay. So this is angle 2. So I got it backwards on the next board. The key here is this is from the previous board. Angle B, the inverse sine gives you the acute angle. But there's another angle between 0 and 180 that has a sine equal to this number. And that's 180 minus B. In other words, think of the unit circle. We've got sine of 35 degrees. And we've got another angle over here that has the exact same sign. So there's 180 minus B gives us the second possibility for B, which is this angle right here. And that's where you get an obtuse triangle. We can find angle A by adding B1 and C together, subtracting from 180, and then finding the side opposite, which is this little number right here, by using the law of sines. One more time. There you go. Hope that helped. If you have any questions, post a comment.